Great. So wonderful. Welcome everyone to Supercharge Your Spring Boot apps. I'm Sandra Ahlgrimm. As we said, we are in the same team. We are cloud advocates working at Microsoft for Java developers. And I'm here with Mark Heckler. Mark, do you want to say a few words about yourself?
Yeah, but I'm just this guy, who loves to code and loves to talk. So talking about coding, it's just kind of my dream gig. So I am Sandra's teammate. I'm happy to say this is the first time we've gotten to co-present together, just due to timing and circumstances. So I'm going to have a great time. Hopefully you all will too.
So let's get it started. Why are we all here? So since we're using cloud native architectures, microservices are coming more and more popular. So when you use microservice, you can benefit from much better scalability. So you scale up and widely as well, so horizontally and vertically, as smooth as possible. You do have high availability in the cloud with more resilient systems. You can use not just your region, so your data center, but the global one everywhere, almost everywhere in the world, where you can spread the load and make sure that your system is up and running every time again. And the main point why we introduced microservices, I don't know, 10 years, 15 years, I don't want to say wrong, here ago, or why it's becoming more and more famous the last 10 years is velocity, right? With the monolithic application at some point. So probably it's easier in the beginning because you don't have to deal with the distributed system things we're going to talk about in a little, but you do have a lot of velocity in the beginning with the monolith. So you can easily set up the whole thing. You don't need to, you still have service bindings, right? So you still have a database and things like that, but with the microservices architecture, that's more complex, but what you get is that your velocity will stay. So your feature release will stay almost same way. So you can have the continuous delivery in place the whole time. And that's the main key things we want to have and we need in our industry to stay fast and productive. So, and then the next challenge, if you use microservices, is service discovery. So microservice needs to be aware where's the next counterpart, right? Because we have this bounded context and usually a context needs to talk to another one as well. So they need to be aware where they are. And usually you want to do this with service names and not giving the IP address with the port number as well. I did that. That was not fun. So try to have that in place automatically. So service discovery, again, is this thing like, I need to talk to you, where are you? And the other one is then replying, I'm over here. So as I said, we need to have that registered with names. So those services can talk easily together, not with having like certain IP addresses and ports, but with the namings. So you can have those things in a registry. So these service IDs, we can say so. And then the producers and consumers can just get those names and addresses from the service discovery. So we need to be aware and register our services, but then we can easily connect to those. And that's why you also need the config server, right, Mark?
Yes. Oh, nice handoff. Nice setup. Yeah, because I mean, it's very important, as Sandra mentioned, to be able to find services, but it's also very important for those services to be able to know what environment in which they should start, right? Because even in the smallest microservices architecture, you have multiple services, multiple instances of each service in well, every case, really, every practical case. So if you have, let's say, 10 instances of a microservice and you have 10 microservices and 10 instances of each, you do the math, that scales out pretty quickly. But let's scale back down just briefly, or scale into that one microservice and the 10 instances of that. So if you want to deploy multiple instances and you want to change something, or you need to change something in the environment, you need to, in the worst case scenario, you need to touch every one of those 10 instances of a microservice. And that's just not practical. And that's just 10, right? So we scale that out even more, as we will in any kind of robust global scale application, distributed application, and it becomes impractical really quickly. With a configuration server, you're externalizing those configuration settings, and then you can either push or pull for updates among your various different instances of microservice. And that gives you a lot of flexibility, a lot of power in your distributed architecture, your distributed system. So as it says, it gives you the ability to do multiple versions of a microservice. You can do zero downtime deployments, redeployments, A/B testing or blue-green deployments, backward compatibility. So if you need to roll out gradually new features, you can still maintain the old features. It gives you a lot of capability and flexibility that you wouldn't have otherwise. Let's go on to the next slide. As well as with anything, there are multiple ways to implement it, right? But the simplest way, the simplest abstraction is as a way to have multiple keys and values. So for this property, we want to have this value that we load into our various different instances of a microservice. And again, I'm kind of keeping it at one microservice, but you do the math, it scales out across numerous microservices in your distributed system. But if you have a property that needs to be set, it is a text property, right? So for this database, we want to use this connection string. For this messaging platform, we have to use this address, this service location. And at heart, those are just textual keys and values. Well, we work with text every day, right? We have a way to version control and audit our code. The same thing can apply to these properties, these textual properties. So we, again, at that abstract level, we look at things like a Git repository, and whether that's local or remote, or in many cases, there's some combination of each, or some other way of implementing underneath that abstraction, you're basically storing keys and values to tell you where to look for certain properties to create that environment in which your application, your microservices will run. Let's go on to the next slide.
Okay, then it's me again. So in microservices, you will spread your business logic potentially across multiple services. And for this one, you need to be able to figure out what's going on. So that's called distributed tracing. So you have the end-to-end transaction graphs in near real time, what you need to collect. So, and that's very important for your monitoring and especially for troubleshooting. So if something goes wrong, why is it going wrong? Where does it go wrong? How did it went? And since when? So we can easily figure out where we need to access and which service we need to access, and then to reduce the issue or to fix a bug if there is something. So what is going on is very important. So if one microservices calls the other and then the next one, and then we might have some potential issues. So that's really important for us to know. And furthermore, we want to be aware how many services we have, from how many instances, and like how many services are on our cluster registered and which service is using what, right? So, and one solution can be Zipkin to use. So you have the Zipkin UI where you can access all these data, and then you have the collector getting those data from all your apps which are in the Spring Cloud. We're going to have a look at this in the Spring Cloud monitoring section later on. So for our agenda today for this session, we're going to start with the Spring application development. So an introduction to Azure Spring Cloud and how to use it and what's the difference between Spring Boot and Spring Cloud. Then we're going to go with the Azure Spring Cloud overview, so what it does and how we can benefit from it. And then we have some little next steps, but I hope we can still squeeze into some live coding, because otherwise it would be just too boring, right? So Mark, what's the difference between Spring Boot and Spring Cloud?
Well, I'm glad you asked. I mean, most folks are aware of Spring Boot, but some folks aren't, right? I mean, in this wide field, we work with a lot of tools. We have a lot of tools at our disposal. So if you haven't heard of Spring Cloud or Spring Boot, excuse me, no big deal. But Spring Boot is, as it says, designed to get you up and running as quickly as possible. I like to think of it as giving you superpowers, because it allows you, based on taking advantage of established patterns in your development of Java applications, Java and Kotlin, I should say, even Groovy to some degree, you have the ability to quickly become very productive with your applications, to concentrate on the business value, the value you can bring with your application to your organization, to your organization's customers, without getting bogged down in the tedium of recreating the same patterns over and over again in boilerplate. Spring Boot handles that for you. Spring Cloud, a lot of times people see the name Spring Cloud and they assume this must be a cloud platform, right? No, it isn't actually. Spring Cloud allows you to deploy to pretty much any cloud platform. Obviously, we have preferences. We have opinions, just as the Spring projects do. But Spring Cloud, as it says, gives you a set of tools that makes communication between microservices easier. So Spring Boot gives you the ability to quickly create productive microservices. Spring Cloud gives you the ability to quickly connect and create the interactions between those microservices. Next slide, please. So once you establish or embrace a microservices architecture, because of the advantages Sandra pointed out earlier, you start realizing that this gives you a lot of velocity, right? It gives you the ability to quickly create and deploy functionality that is super productive, that scratches your users and customers' itches, if you will. But it also gives you this kind of explosion of different microservices, right? Because you're distilling to their essence the capabilities within each one. So you go from one big thing, even though it may be rather unmanageable, it's one thing and you're going to many things. Well, you need certain tools to help you make sense of them and to manage them, things like your circuit breaker dashboard. So you can see what's happening if something fails and where the requests are then rerouted to make sure there's no system failure, just an application failure. It's isolated and handled. You have a service registry, which Sandra mentioned, the configuration server, which I mentioned. Of course, you have a dashboard for that as well. Distributed tracing, so you can follow things, the requests and responses all the way through the entire system. You also have things like interactions and integrations with message brokers and databases, an API gateway to control and manage access to the entire system. But you start to realize pretty quickly that even though you had maybe a handful of microservices, you now have a handful of supporting services that help you manage and maintain that, which is great. It gives you more tools in your toolbox, but it also gives you more to manage. So this is where some of the challenge comes in when you start deploying microservices architecture. Next slide, please. Which is why it's so important to have something like Spring Cloud and by extension, Azure Spring Cloud. If you look at this diagram, kind of in the middle, the kind of to the right, under user environment, that top level, these are your business value adding applications, that app 1, app 2, and app n. Yes, thank you very much. So those are the things that actually deliver on the promises you're making to your users and customers. However, once you start coordinating all of these, and again, each one of these is not an island. It has to talk to others. It has to interact with databases and messaging platforms and external APIs. And once you scale out, so app 1 may have 10 or 20 or 100 instances of app 1 and so on and so forth. You need these other things to help you control and manage these things. And that's where it starts, you see this explosion of effort and additional services. And of course, you deploy them on something like Kubernetes to run at scale globally, wherever you need it. If we go to the next slide, we see kind of how this all fits in, because Microsoft and VMware saw that this this is very powerful, right? But it also gets out of hand very quickly. You need tools that work for you instead of making you work for them. So Microsoft and VMware partnered to supercharge your Spring Boot apps by delivering Azure Spring Cloud, a platform that gives you the power of Kubernetes, but actually allows you to more manageably handle those microservices and, again, deliver that business value to your end users. Next slide, please.
Okay, so Azure Spring Cloud is our fully managed Spring Cloud service. As Mark said, it's jointly built and operated with VMware. So you have more choices and full integration into Azure's ecosystem and services. So why don't we have a look and give it a try with our demo? Because we still have time. So here's a Spring Cloud cluster we created already. And here's my overview. I can see here my apps. So we can also quickly look into how it looks like into my API gateway and get the URL in a new tab. So as you can see, we just deployed the famous Spring Pet Clinic you can find at the Spring examples. So you can have a look at the owners and see all of them. They are all stored in Azure databases. And yeah. And then we can have a look into the monitoring. So here are my applications. And if I want to have a look in the monitoring, I can go with application insights. So that's where we're making use of Azure's powerful tooling here. So here I can see already my server requests for the last 30 minutes or for the last hour, sorry. also the server response time and failed requests and everything. What I find very useful is the application map, because now it's not super complex, but you can imagine, and you probably all have been to those famous Netflix sessions where they admit that they actually have more services than they are aware of, because they have a lot of microservices. And I fear that's probably not something you want to have. So you want to be sure what's inside your cluster, who's talking to whom, and also filter that you can see who's performing how. So now I can actually go to my API gateway and see very quickly the logs, also get all the requests I can use to talk to this service. Yep. And I can also investigate in performance right from here. Or I go another way, I can show you quickly. So here I can see actually the performance for my requests available. I can also check the performance of my dependent services. So here I can see the services this service is using, and I can also filter by worlds, so that I here have my application gateway and then see how much available memory I have and the average duration and so on and so forth. I also can make use of smart detection. So if something goes wrong, the Azure Cloud is actually helping me to get some like performance issues. It will point me out to this. I can also use the live metrics, which comes very handy if you have something like Black Friday, or you're running some load tests on your testing environment, so you can see how it's going. And or if you have a new feature release, you can also check how it's perceived and if everything is going well. You can also filter by failures. And here again is the performance tab. What we haven't looked at yet. Yeah, I can also check the costs, and I think I missed something. Yeah, here's also monitor by alerts. So I also will need that. I can create a new alert rule, and then based on metrics, I can say that I want to receive an email or something. And those metrics I can check from here. So these ones are all built in. I didn't have to do anything to get this. They're all built into Azure Spring Cloud. So I can filter by availability, page load, network time. I can use some custom metrics like GC total count or my heap memory used, or I go with the JDBC metrics, with the JVM metrics, even process, CPU, Tomcat, you name it. So it's all available. Also, I can get my Zipkin monitoring here. I can filter by failures, usage, you can see here, and that's all built in. I didn't have to do anything. And I feel that's very, very useful to have that. I remember how much time we spent in the previous products to get this one. And this one is just there. You can just use it. So I feel that's very handy. So if you're using Spring Cloud, we have the Azure monitoring right in place, and also the deployment. Mark, why don't you take over and do a little bit of live deployment? Let me see how I can stop sharing.
Okay, I was going to say, I'm not sure we'll have time, but you know what? Why not? Why not give it a shot, right?
Yeah. Can somebody tell me how I can stop sharing?
I think I have it. So
Yeah,
let's see if I do this, and that pops that there. So now I see you, and let me, oh, it's not letting me move. Oh, hold on. I'm not done yet.
There it is.
Now there we go. Oh, look at this. I have multiple windows open. So let me move this over and maximize this. All right. So can everyone see my screen?
Yeah, and it's the same window, isn't it?
Yes. Okay. Well, good. I have this up. So this is the, see, cute. All right. Anyway, no time for cute. All right. So very quickly, I'm going to create just a super simple application that we're going to deploy and just have it integrate within our Azure Spring Cloud microservices deployment. So I'm going to create a Java application using Maven as my build system, the current version of Spring Boot, which is 2.5.5. I'm going to just change the group to Sandra and Mark. .com sounds like a great company. We should do that. So let's see. I'm going to make an owner API, something to expose the owners, the API of the owner, so we can query those and do something with them. And again, this is going to be necessarily very simple because we only have about 5 minutes. But use your imagination. It's a good start. So I'm going to add some dependencies. I'm just going to bring in the reactive web dependency. If I can type reactive web. And that isn't necessarily because we need anything reactive, but that gives us access to the reactive web client, which polls both blocking and non-blocking endpoints, which is good. Flexibility is good. I'm going to bring in actuators so we can monitor our application, see if it's up, down, status, things like that. And then I also want to make sure that we have the discovery client, so we integrate with our service registry. And then, of course, Lombok, because I am an unashamedly lazy developer, lazy good. I just want to clarify that, not lazy bad. And I'm going to save this down. Let's just drop this on my desktop. We'll open up the project very quickly. Let's see. Why did that do that over there? I love exciting times, right? So let's open this up in our favorite IDE, NetBeans. Kidding. I'm not picking on NetBeans. It's, I pick on, well, I am, but I pick on my friends, so it's good. So I'm just going to open this project now in IntelliJ. Use what makes you happy. I also use VS Code. I could have actually created the application via VS Code and IntelliJ via the plugin. You can also curl it, HTTP it. You have options. This is just one of your many, many options. So I'm going to just open up the, come on, IntelliJ. Now you're making me look bad. We have our dependencies here that we chose. That's good. I'm also just going to open up our application code and let's get started. So we want to do a couple things. I'm going to start with my domain. And again, I'm using Lombok because I'm lazy to create a data class. This makes it very simple. It reduces a lot of boilerplate. Boilerplate's generally a bad thing. So I'm going to I want to pull our owners from our owner service, our customers service in our existing deployment of Pet Clinic. And we have things like our owner's first name and last name and address and telephone, I think we could probably safely do. And then, of course, we want to create a controller of some kind. So I'm going to create a REST controller. We'll call this, cleverly enough, our owner API controller. And we will need something to pull that external source of owners information. So we're going to create a reactive web client. We'll just do that with web client.create. And we want to point this to our owner API or our owner service behind the scenes. So we also call this our customers service, right? And we're using our discovery server so we can use our service discovery mechanism to just point to a name and not a location, and not a specific location. So this will be our owners. So that looks right. I want to make sure I don't typo here because typos generally are bad, computers being so literal as they are. And then let's go ahead and build our API. Now, I like to just create a simple get mapping here so I can just return something like a greeting so I can test things, greeting, and we can just see if it works. So return greetings J4K. That's good, just to make sure everything is up and running. And then let's get down to business here. We want to point to maybe our owners so we can check out the owners if I can type. And I'm going to return a flux of owners. And this is just a reactive publisher type. Think of it, and this is oversimplification, but think of it as kind of a list that populates as values come in, not at all at the end. So more details can be provided later on that if you'd like. So get owners, that's kind of the high level, right? So get owners, and we're going to just use our reactive web client here. To get those owners, we'll retrieve the values. We'll convert the body to a flux. Again, that's a publisher of 0 to n values of type what? Of type owner, right? So we're going to return that. Now, just because, and of course, time being of the essence, I'm going to copy paste. Don't do this at home or in production, but we'll do this for now. I'm going to return a single value, a mono, if you will. I'm going to just point that to owner. I'll do get one owner, and we'll just grab the first one off the pile, right? So we'll do that. So that should work. Now I'm going to flip over to terminal here. We'll go to desktop and our owner API. I'm just going to do a Maven clean package and we'll build that. And then let's deploy that. And while it's deploying, I can point to a couple of things, and Sandra probably can't wait to take back over again because she's going, oh, this could have been so much better, and she's absolutely right. But you do what you can with limited time. We have a minute, so actually, you know what? I'll start the deployment. Well, I'll show you how I do the deployment, and then we'll go out and look at the one that I had before. The error messages you see are just because I don't have a local instance of my service registry. Completely expected, so that's not a problem in this case. Generally, I don't advise to ignore errors, but this is it. You do an Azure Spring Cloud app deploy, and you point it to your target, and out it goes. So since we're limited on time, I'm just going to go back here, show a couple quick things. Of course, this is our pet clinic application. That's all working, everything. But let's see. Oh, I've got this semi-obscured by this sharing thing. So let's just try to go to our admin server. I like to point this out because this allows us to see kind of behind the scenes look to see what all is running. Block our notifications.
Thanks, everyone.
What's that?
I think we're ending now.
Oh, okay. Well, let's go to our owner's